Morning, Lee. Manfred and I decided the best way to describe Henry and everything was to do a quick video for you, and maybe you can show the kids and the faculty there exactly what we're trying to accomplish. Well, as you know, obviously you know, we developed this cool bottle that turns into a tile, right? And a whole bunch of stuff about it, right down to its packaging, so we can keep the package as efficient as possible for the carbon footprint. Every detail of this bottle is real important to us. And but specifically, obviously, is the ability to manipulate it, to fold it from a bottle into a really high-tech, really high-quality building component, this tile that we designed. And as we've gone through this process, we really have learned that our tile is of a lot higher quality and has a lot greater function than we ever dreamed it could have. So we really need now to focus on how do we turn this into this. Okay, big deal. It's a couple-step process that isn't that easily done manually. The design was these triangles on the corner here, these bulbous triangles here, have to first be depressed inwards in order to fold it properly. They have to go inside. Okay, so when we do that, we start to press these guys in, and we can do it by hand, pretty much. But you can see it'll bend in areas that we don't necessarily want it to bend in. But again, we can do it, and we bend this one in. So the first process in the steps is to bend in the triangles on the side. And that triangle extends about up to here. Okay? Then we have another couple features of the bottle. We have this groove right here, this fold groove at the bottom of the bottle. And that really accommodates our second process, which is to take and bend this piece over. That's the process. The first one is corners in, fold this over, and then there has to be, that all comes together to create this depression in here. This depression is really super important, and these folds are super important because it's that fold that we designed that locks the tongue into place really strong. That tongue is really strong. It's locked into place by this arc that's created in there. So this consistent folding, and this angle is also critical. This angle is the angle that nests one tile to the other. This fold is where we hold it together. These are the things that we had to accomplish with that machine. Well, we went ahead and we started to develop that machine, and we called it Henry. And you'll see now in the rest of the video how Henry really has accomplished this. Some new stuff that we'd like to see Henry be able to do is Henry should be able to pinch this fold right here and at the same time sonic weld it together. That would be ideal for us. So the students should think about how can we do that? It's a super strong, super durable tile. It's these folds on the inside that give it its lightweight, it gives it architectural volume, and it also gives it its strength. There's a whole series of arcs and triangles working together to make this thing like indestructible in reality. So we've achieved the first goals. We've created this incredible tile, and we started with this bottle that everybody liked. We called that now, what we're calling this, Lee, is the surface area of this bottle is exactly the same surface area of this tile. So what we've really done is we've manipulated surface areas to change its volumes. If we went ahead and we wanted this tile, right now in today's industrial processes, it would be very hard to mold that in one step. Its aspect ratio is wrong. We couldn't have this dead airspace, this thin profile. It would be impossible to blow mold this. So we had to do it in a two-step process. First, blow mold a void that we can use as a container. And then later, with a Henry, with a machine, manipulate its exact surface area to come up with a tile. So really how we've done this is we've worked backwards. We've said, okay, these are the qualities we want in a tile. And what would it look like if we expanded it into a void, into a container? And it looks like that. Truth of it is we got kind of lucky. People like what it looked like. So essentially, that's pretty much what what we got to do, and that's what we've accomplished. And now you could just get the students to go through that process. We need a machine that goes clack, pushes in the triangles, folds it over there as step number 2. Step number 3, it hinges right along this joint here. And step number 4 creates this void. Okay, now with that information and supplemented with the video stuff that Manfred's presenting, you should be able to have a really good idea of what we need and where we're at. Okay, thanks Lee, have a good morning.